Hello everyone, I am Rohit Mavarakar. I am welcoming to our channel, that is Mavarakar Science. Okay, today we are going to continue our chapter 1 of class 10th standard. That is, which chapter we are continuing? That is chemical reaction and equations. Okay, yes. Previously in the class we have discussed about the chemical reaction, right? We have discussed about the meaning of chemical reaction, some activity, and what do you mean by all the chemical reactions. Okay, and today we are going to study about the continued part, that is chemical equation. What we are going to study, that is we are going to study about the chemical equation, all of you, right? Yes. Okay, we will continue now. Before continuing the chemical equations, I want to introduce about me. Myself, Rohit Mavarakar. I have completed my BSc B.Ed from Gokak, working as an assistant teacher in Ankalgi, right? And also interested to teach science from 6th to 12th standard students. Yes, we will continue now. What we will continue over, that is chemical reaction and equations. Previously, we have discussed about the meaning of chemical reaction, right? Chemical reaction, we have discussed the definition. What do you mean by that? Nothing but any change in any state, change in any color, or something that is evaluation of gas is taking place, or something that is changing in the temperature, or sometimes formation of precipitate, right? All these activities, if you are finding any one, means it can be said as chemical, what it has changed, that is chemical reactions. Okay, yes, we have glanced about the definition. Yes, sir. Our the main topic, chemical equation, a simple representation of a chemical reaction in words is called as a word equation. What do you mean by that? Instead of writing a reaction in the sentence, no, we will represent in the word form. That is called as, what it is called as a word equation. Okay, yes, we will move on there. Yes, all of you, I think you are visible in our slide that suppose the statement, the magnesium ribbon is burned in the air to form the magnesium oxide. See, this statement is little bit very lengthy, no? So we will reduce in the statement to word form. What we have done? We have done magnesium plus oxygen is equals to magnesium oxide. Okay. See here, all of you. Whatever in the reaction, no, whatever we are seeing in the left side, it is called as a left hand side. In the whatever the in the left hand side is there, no, it is called as a reactant. Okay, left side whatever it is present, it is called as a reactant, and whatever in the right hand side present, no, it is called as the products. Okay, keep remember this word, very important terms are there, which reactant and products. Yes, what you have discussed, that is chemical equation is nothing but a simple representation of a chemical reactions. Yes, we are in the word form, left hand side what we call as, that is reactant, right hand side what we will call as a products. Okay, see here, both Reactants and products are differentiated with the help of an arrow. Is it visible for you? What the arrow indicates? The arrow indicates to yield and to show the direction. To yield means usually uh, in the reactants more than one or two reactants are there, no? What the product it will give, and sometimes direction means whether the reaction is reversible or irreversible it shows. Yes, a chemical equation is a shorthand form of chemical change. Okay, again we have word equation, no? Instead of word we will make as a alphabetic form. Mg plus O2 is equals to MgO. Left hand side whatever you have read called as reactants, right? Right hand side we will call it as a products. Again we have differentiated with the arrow mark. Arrow indicates to yield and to show the directions, right? If the number of atoms of each element on the both the sides is same, then it is balanced equations. Else equation is unbalanced or skeletal chemical equations. What I mean by basically, see here all of you. If the number of atoms of a element is not in same in RHS and LHS, no, it is means unbalanced. Unbalanced means not same. Balanced means same. Okay, yes. So above reaction is a example of skeletal equation. What do you mean by skeletal equation? I have already said that is nothing but a this example is a unbalanced, right? It is an unbalanced equation now. Yes, steps involved in writing the chemical equation. It is the reactant side, it is the product side. We will just take a simple example. Reactants, usually where reactants are written in the LHS. LHS means left hand side, right? And products, right hand side. Reactants and products are separated by a arrow mark. If two or more reactants are separated by plus sign, the conditions mentioned on arrow mark means what type of the condition should be required to make a reactions. It will show that physical state of reactants and products to make the reaction more informative. Physical state means whether it is a gaseous is there, solid is there, liquid is there, semi-solid is there, whatever is there, the physical state it will show. Yes, all of you. We will continue to start over the balancing the chemical equations, right? So before going to balance, have you remembered the small concept like have you remembered about the law of conservation of energy? Conservation of energy, right? You know what happens, this energy neither be created nor be destroyed, but it can transfer from one equation to another equations. Okay, same here the mass also is in the reactions usually neither be created nor be destroyed, but it will be same on both reactant and product side. See here all of you, if suppose it is a example of a reaction now, if the reaction is a plus 1 a plus 1 a plus b is there, no, the mass will be the 2, it has not exchanged or decomposed, same is there. Okay, total mass of reactant in the reactant is equal to total mass of product in the product. See here, with the help of equation we will try to identify. Zinc plus sulfuric acid is equal to zinc sulfate, hydrogen. Yes, zinc is Zn, sulfuric acid H2SO4. Okay, I think this reaction is invisible for you. ZnSO4. Okay, and hydrogen. So we will compare the both now. We will compare whatever the elements in the reactant side, and we will compare the products in the element in the product side. Zinc, which is present in the left hand side, it is also 1, and in the product side also 1. So it is the balanced equation now. Next element is hydrogen. Hydrogen in the reactant side is 2, and in the product side it is 2. So it is a balanced now. Sulfur. Sulfur in the reactant side is 1, and sulfur in the reactant side is also, products also same. Oxygen. Oxygen is also 4 atoms are there. Here is also 4 elements. So finally this equation is a balanced equation. This equation is nothing but a balanced equation, right? As the number of element is in the same on both the sides, hence it is called as a balance equation. Means step 1. We will take another example all of it. So here we have reacted the iron with water. What for ferric oxide all of it, and we will release the hydrogen. To balance now, we will do one thing. We will draw boxes on each formula. Yes. Step 2. List the number of atoms of different elements. Means which is different elements are there. Here which is different elements are there all of you. We are having iron, oxygen and hydrogen. So we have to balance all these elements. Yes, we will start now. Iron in the reactant, how many products are there? 1. So in the product side 3, it is unbalanced now. Hydrogen in the reactant side 2, in the product side 2, it is balanced now. Oxygen in the reactant side 1, and in the product side it is 4 is there. So here only hydrogen is balanced all of you. Okay, and we have to balance now iron and oxygen. We have to balance. So step 3. Start the balancing compound that contains maximum number of atoms. Means maximum where we are having, we have to start that. Atoms of oxygen in Fe3O4 all of you. First in the oxygen in the hydrogen is, in the hydrogen molecule is 1, and in the Fe3O4 it is 4. So to balance, what you have to do, we have to in the reactant side we have to multiply with 4. So in the products automatically it will be 4. For example, to balance the oxygen atom, no, we cannot put a coefficient as 4. Step 3. We cannot alter the formula of compound or element to equalize the number of atoms. Step 4. Let us balance the hydrogen. Let us balance the atom partially. Means now we balanced the oxygen all of you. Now what we have to balance? We have to balance the hydrogen now. Initially in the water molecule 8 molecule ಇದೆ, and in the product side 2 are there. So to balance we have to multiply 2 with 4 to get 8. Step 5. Let us balance now iron. We got balanced now. We balanced now oxygen and hydrogen. The last one is iron. We have to balance that. Atoms of iron, all of you. In the reactant side, iron is only one element is there. In the product side, 3 are there. So to balance, you have to multiply 1 with 3. So automatically our product side also get balanced. Step 6. So whatever this type of balancing is there now, it is called as hit and trial method. Step 7. Physical state of reactants and products are mentioned along with the, means whether it is a gaseous is there or solid is there, or we have to represent that. I hope this equation is get. So the balance equation becomes 3 FeS plus 4 water molecule plus is equal to Fe3O4. So 4:8. Are you looking that? It is our balanced equation now. Okay. Step 8. It is the last step of it. Sometimes the reaction conditions such as temperature, pressure, catalyst state, etc. for the reactions are indicated above and or below the arrow mark. For example,